Here we have an Excel spreadsheet to calculate some of the examples that I was demonstrating earlier. The first one is for a normally distributed random variable with a mean of 60 and a standard deviation of 18, as we saw when discussing the General Electric and Jack Welch example. And I asked, what was the probability that x, that standard normal random variable, the random normal random variable that was representing the score on the management assessment, what was the probability of getting a score at least as big as 92? And you can see that it's about 0.0377, and the formula for calculating that was 1 minus norm dist 92, which is that x value, 60, which is the mean, 18, which is the standard deviation, and then 1, which is what we always put for the cumulative distribution. I added two more just for your personal edification, to show how to calculate the probability of being less than something, which is actually easier. Instead of doing 1 minus a norm dist, you can just do the norm dist function. I also thought, what about the calculation of the probability of being between two numbers? And to do that, you take the larger number. I'm asking, what is the probability x is between 55 and 65? And so I start with the larger number, 65, and I take the area to the left. And then I consider the second number, 55, and I take the area to its left. And if you subtract those two numbers, you get the area in between 65 and 55, which is in fact that probability that you see there is 0.2188. I next did two calculations using the norm inv function. What these are doing is calculating the membership into the top 20% and the bottom 10% of those management scores. So if the average is 60 and the standard deviation is 18, and you have a score that is 36.93 or below, then you're in the bottom 10% and you're likely to lose your job. If you have a score that is 75.149 or greater, then you're in the top 20% and you're likely to get a raise. Below, I did the calculation for Densa and Mensa, which I showed in the example, but here's the Excel formula for doing the computation. It's just a norm inv for the bottom 2% with a mean of 100 and a standard deviation of 15. And that puts you in the bottom 10%. That gives you the value x such that 2% of the area is to its left, and the answer is 69.193. And the value x such that 98% of the area is to its left, which means 2% of the area is to its right, would be 130.806. So on the whiteboard I used 69 and 131 as estimated values for that. Lastly, I did the calculations I showed for those quick estimates, and in this case I used the norm dist function, which is for a standard normal random variable. It says that the probability of being between +1 and -1 standard deviations from the mean is about 2/3 or 0.682. And the probability of being between 2 and -2, which is the probability of being within two standard deviations of the mean, is about 19 out of 20 or 95.4499%. And again, the probability of being within 3 standard deviations is 0.9973 or about 399 out of 400 tries. So here's the way to use Excel and those Excel functions, and I will of course forward this Excel spreadsheet onto you probably by the time you're looking at this video.